Hello students, welcome back to Algebra 2. Today we're going to talk about modeling with quadratics. This means that we will be given real-world situations and we will be required to come up with a quadratic function that represents that situation. So this comes in a variety of different methods. So the first type that we will do is when we were given the vertex and a point. Now, if we're given the vertex and a point, we're going to want to use a formula that we remember as vertex form, or maybe transformational form, depending on what textbook you're using. But that would look like this. F of x is equal to ax minus h squared plus k. That form is very useful because I can use h and k to represent the vertex, and then using the second point, a is very easy to solve for. The other one that we might do is given the intercepts and a point. And in that case, we'll want to use intercept form or root form, again, depending on which textbook you're using. F of x equals a, x minus r1, x minus r2, where r1 and r2 are the x-intercepts. And again, once we know those two, this form makes it very easy because we can just plug in root number 1, root number 2, and then use the other point to figure out what a is. And another way we could do it is if we are just given 3 points. And the first way we can do that is we can write a 3-variable system. But let's not do that. That's hard and we have better tools. Instead, we're going to use quadratic regression. This is a much more efficient way, and this allows us to use our technology to quickly come up with an equation for our quadratic. So let's get into this with some examples. So the graph shows the parabolic path of a performer who is shot out of a cannon, where y is the height in feet and x is the horizontal distance traveled in feet. Write an equation of the parabola. The performer lands in a net 90 feet away from the cannon. What is the height of the net? So what I see here is that I do have the vertex and a point, so I'm going to go ahead and use vertex form. Y equals a, x minus h squared plus k, but I see the vertex is right here at 50, 35, and then I see I have this other point right here, 0, 15. So that means that 0 is x, 15 is y, and then 50 is h and 35 is k, so I can just go ahead and start plugging those in. 15 is equal to a times 0 minus 50 squared plus 35. So 15 is equal to a 0 minus 50 is negative 50, and negative 50 times negative 50 would be 2,500 plus 35. So I can solve this by subtracting 35, get negative 20 equals a times 2,500, and then we'll just divide by 2,500 on both sides. And negative 20 divided by 2,500 is equal to negative 0.008. A is negative 0.008, which means the function is y is equal to negative 0.008 x minus 50 squared plus 35. So if the performer lands 90 feet away from the cannon, what is the what is the height of the net? So looking at this, I see x is the horizontal distance. So if the horizontal distance is 90 feet away from the cannon, That means I'm just going to plug in 90 for x to answer that question. Y is equal to negative 0.008, 90 minus 50 squared plus 35. Now I can actually just go ahead and type all of that in, negative 0.008 times 90 minus 50 squared plus 35 equals 22.2. So, of course, this is a word problem. We answer in words. The height of the net is 22.2 feet.